Hello everybody, hope everyone's doing well. My name is Anthony Lass and I'm here with my partners Fernando Mendoza, Jimmy Higgison, and Jesse Munoz. Today we will be explaining our senior project, which is building an oxyhydrogen electrolyzer for data collection and optimization for a new design. More specifically, we will be using it to find the most efficient method for collecting oxyhydrogen by using the electrolyzer to separate and collect the oxygen and hydrogen gas mixture through the process of electrolysis. To find the most efficient method, we will be considering the important factors such as current, voltage, size, number, and material of the plates, and the different catalysts being used. Our objectives to this project are to design and build the electrolyzer, test the electrolyzer, experiment with the different factors and collect data, analyze the data, repeat the process to improve efficiency and achieve our goal, optimize the electrolyzer for the best performance and to increase the production rate, and our last objective to this project is to demonstrate that the experiment functions as expected. Now I'll be passing it over to Jesse to go over the background and main goals of our project.
Thank you, Anthony. Hydrogen production electrolyzers were introduced in the late 1700s by Henry Cavendish. Electrolysis is the process of breaking down water into its hydrogen and oxygen molecules with the passage of electric current through the water. Pure water is used for electrolysis process of hydrogen, and to increase the electrical conductivity of water, catalysts such as potassium chloride, sulfuric acid, and potassium hydroxide are used. There are two types of electrolytic cells: a wet cell electrolyzer and a dry cell electrolyzer. In a wet cell electrolyzer, the entire electrode material is submerged into electrolytes, whereas in a dry cell, the electrolytes are inside the rubber gaskets and separated by electrode plates. This will be accomplished by building an electrolyzer, build an experiment, collect and record data. The data that is recorded will be plotted and compared, adjust for optimum hydrogen collection, we'll be making conclusions, and finally we'll be demonstrating and creating a soap foam mixture to ignite to show the combustion effects of hydrogen. I'll be passing it over to Fernando, who will be doing or talking about conceptual design.
Thank you, Jesse. As you said, I'll be talking about the conceptual design, specifications, and our budget of this project. So for our design, we made on SolidWorks right here. It consists of three main parts. We have the polycarbonate plate, our steel plates, and our neoprene gasket. For our plates, these are the main holes. There's 3 holes on every side, and that is for our bolts to hold down all the plates and gaskets together. And then we have one small hole that is right here, and that'll flip up and down to have the electrolysis process flow thoroughly through the whole electrolyzer. This is the QFD we use to complete our specification for the entire electrolyzer. We'll actually be making 2 electrolyzers, one containing of aluminum and one having stainless steel plates. The plates are 1 millimeter thick, and they coincide with each other. It'll be just gasket plate, and there's actually 2 types you can make, and one's a square or rectangular shape, and we'll be going with the square shape. Our main focus will be trying to get a consistent flow rate of hydrogen and oxygen coming out of the electrolyzer. The main power range for our variable voltage will be between 2 volts and 12 volts, and the catalyst that we chose to experiment with will be potassium chloride, and this budget came about to be roughly $1,500. And this is the breakdown of our budget. The main cost that we really had was our plates and gaskets. I'll be passing on to Jimmy right now.
Thank you, Fernando. So I'm going to show you guys the deliverables. Some of the deliverables for this project include efficient oxyhydrogen producing electrolyzer, SolidWorks detailed drawings and assembly, the data results for the different factors such as voltage, current, the catalyst, and the material used, the data analysis for the optimized design, our economic impact on the automobile industry, and the risk assessment for this electrolyzer. So here's our schedule and basically where we're gonna start and end with this project. Most of the time taken up will be 4 to 6 weeks for ordering and waiting on the arrival of the parts, which will begin August 24th. Once the parts come in, we intend on starting to assemble this around the October the 12th, and we intend on having this built and completed by November the 10th. By November the 17th, we'll begin testing and data collecting, and then we should finalize our data collection results by November 26th. And by doing so, we will practice and present and finish our report and presentation by December the 7th. Some of the definitions that will be pertinent to this project would be the electrolyzer, as we've already stated, and electrolysis. The brown gas, which refers to the oxyhydrogen ratio of H2 and O2 gases, which is going to be the same proportion as it is in water. HHO, which is an acronym for oxyhydrogen. KOH, potassium hydroxide. NaCl, sodium chloride. And KCl, potassium chloride, which are all catalysts that can be used or tested in this project. The one that we are choosing to stick with, as Fernando stated, is potassium chloride. Now, to conclude this project, as we showed you in the schedule, we'll be starting this around the middle of October, and in completion of this design, we'll be attaching the water supply, power supply, and gas collector. The design will be tested to ensure that everything is functioning the way that it should, and changed or modified as needed. The collection of the data will begin for the different factors being tested, and the optimum design can then be considered for the most efficient producing electrolyte, HHO producing electrolyzer. Thank you.